Hello everyone, welcome back to our channel. So in previous video we had studied the Lami's theorem. We have seen example related to the Lami's theorem. So in this lecture we will try to solve a numerical based on the sphere. So first we will read the question. A cylinder B of weight 1000 Newton and a diameter 40 centimeter hang by a cable AB of length 40 centimeter. Rest against a smooth wall. Find out the reaction at C and tension in AB. So this is the given question. This question comes under equilibrium chapter. So all the questions related to the sphere will be considered under equilibrium. So this question was asked in May 2013 in the Mumbai University question paper. So before the solution, we'll assume few factors like system always is in equilibrium. It means that the net forces and the moment acting on the system are equal to 0. So though it is not given in the question, we'll assume the system is in equilibrium. Second condition is that we'll apply conditions of equilibrium. So there are three conditions of equilibrium. After that, we'll consider it forms a concurrent force system. The line of action of all the forces will pass through the center of the sphere. So here we got only two conditions of equilibrium, that is summation of fx is equal to 0 and summation of fy is equal to 0, as it is a concurrent force system. Now we'll start the solution. So first we'll draw the FBD of the given sphere. Then we'll show the center of the sphere here because it forms a concurrent force system. Then draw the x-axis and the y-axis. So this is your first quadrant, second quadrant, third quadrant and the fourth quadrant. So with respect to that, we will show the forces on the system. So first we'll show the weight force. So weight of the sphere is 1000. So weight always act in the downward direction and it is a vertical force. So we'll show it starting from the center and in the downward direction. So this is the value of weight and it is equal to 1000 Newton. After that, we'll have a reaction here. As we know, this sphere is applying some force on this wall. So as per the Newton's third law, every action has equal and opposite reaction. So this wall will offer a reaction to this sphere. So that is shown here. Now when we draw a reaction, we should follow certain rules. So what is the rule number 1? Reaction is perpendicular to the surface in contact. So for this surface, the reaction should be perpendicular to this surface. So it forms a 90-degree angle here. The second important rule is reaction always passes through the center of the sphere. So all reactions should pass through the point B or the center of the sphere. Then the third rule, direction of the reaction is always toward the center of the sphere. So this reaction should be pointed towards the center. So these are three important rules that we should know. The rule number 1 is reaction is always perpendicular to the surface. Reaction always passes through the center of the sphere and reaction always act towards the center. So if you know these three rules, you will not make mistake while drawing the FBD for the sphere related problems. So we'll show it here, and it is, as you can see, it is pointed toward the center of the sphere. So same RC is shown in this FBD. Then there is a tension. When we cut this rope or cable AB, we can see a tension is visible in this cable. Now opposite to the reaction, tension force always act away from the center. Okay, so this difference you should remember. Reaction force act towards the center, tension force act away from the center. After finding the reactions for the FBD, we should find out the angle made by this tension AB with the horizontal. So for that, we'll consider this triangle. The length of AB is given, it is equal to 40 centimeter, and the base of this triangle will be 20 centimeter. Why it is 20? Because the diameter of the sphere is given 40 centimeters. So half of that will be the radius of this sphere. So it is equal to 20 centimeter. As we know, two sides of this triangle, we can easily find this angle made by the tension with the horizontal. We'll call it as alpha. So now cos alpha is equal to adjacent side divided by hypotenuse. So 20 divided by 40. So we'll get alpha is equal to cos inverse of 20 by 40. So alpha is equal to 60 degree. So in this way we can easily calculate the angle of TBA with the x-axis. Now we have got all the parameters here. So we'll write it here. Now we'll transfer this force in this direction. As per the principle of transmissibility, we can transfer the force along its line of action. It is valid only for the rigid body, and all the bodies we considered in the mechanics are rigid body. That's why we can transfer this force along its line of action. So RC get transferred here. Now we get a system for which we can apply the Lami's theorem. Lami's theorem is applicable only for the bodies in equilibrium, only for three forces, only for three concurrent forces, and only for the forces pointing in the same direction. So we had satisfied all the conditions required to apply the Lami's theorem. Now we can start with by applying Lami's theorem. So first start with the known force. So 1000 divided by angle between remaining two forces, that is angle between TBA and RC. So total angle is 180 minus this angle 60 will be 120. The next force is RC. Remaining two will be TBA and 1000. The angle between them will be this 90 degree plus 60 degree. So it is 150. The next force is TBA. Two remaining forces will be 1000 and RC. The angle between them is 90 degree. So it is TBA divided by sin 90. So in this way we can apply the Lami's theorem for this system. Now we'll compare this value with this value. So 1000 divided by sine of 120 is equal to RC divided by sine of 150. So to calculate RC, we should multiply sine 150 to the left hand side. So it becomes 1000 into sine of 150 divided by sine of 120. It is equal to RC. Now the value of RC is equal to 577.3 Newton. Now we'll compare 1000 divided by sine 120 is equal to TBA divided by sine 90. To calculate the value of TBA, tension in BA, we should multiply sine 90 to the 1000. So it becomes 1000 into sine 90 divided by sine of 120. So it is equal to TBA. Now calculate the value of TBA. So TBA is equal to 1154.7 Newton. So in this way we can solve this numerical by applying Lami's theorem. For that we should be able to find the support reactions and show all the forces for the given system. To show the support reaction, we should follow rule number 1, 2, 3. What is rule number 1? It should be perpendicular to the surface in contact. Second rule, it should pass through the center of the sphere. And third rule, the force will point towards the center of the circle. To draw the tension in any cable, we break that cable and we'll show the tension force there, and it acts away from the center. So if you follow these basic rules, then you can easily able to solve sphere related problem, and always there is one question based on the sphere either for 4 marks or 8 marks to find the support reactions. So that's it for now. Thank you for watching this video. Thank you very much.